Hello everybody, I'm here with an example of a machine. In this case, a very simple example of a pliers. As you could see, a force of 100 Newton applied to the handles. And we want to figure out what is the output force that is developed at this point, at point B. Okay, so this is holding a pipe or something. And we want to determine what is the that output force or clamping force. So we want to find the clamping force at B. So basically this is the input, the 100 pound applied to the two handles, right? And we want to figure out the output. All right, so we'll go ahead and try to draw a free body diagram of this. And the free body diagram could be either the free body diagram of the upper handle or the lower handle. Doesn't make any difference. See if I can draw the free body diagram of the upper handle for you here as best as I could. So you see this is the 100 Newton force that is applied. And then right here, this is that output force, which I'm going to call it normal force, N sub B, which would be perpendicular to this surface, right? So actually, the force that is applied by the jaw to the pipe, this is the reaction force to it, okay? And at A, what do we have? This is basically a pin, so we're going to have the pin reaction AX and AY, right? Remember, I didn't define actually a machine. A machine is main purpose is transmit the force. So you're applying the 100 Newton force and hoping that to get much larger force at the output. And we'll see what happens here in this case. If we apply 100 Newton, what are we going to get over there? 3 times, 4 times, 5 times, and so on. And obviously that depends on all the dimensions. And by the way, unlike frames that are stationary, obviously if machines are not stationary, if this pliers is not stationary, you're applying to the forces, applying forces to the handles, right? So look, this is a very simple problem. Just take moment about A, right? Say it equal to 0. Let's say counterclockwise is positive. The moment of this force, NB, about A is times this perpendicular distance, which is 50 millimeter. You could actually stay with the 50 millimeters. So that's 50 millimeters going clockwise. And then the moment of the 100 is 100 times 250. So you see, basically your output becomes 500 newtons. This is very good. In a way, you could say the F out over F in this case is 5, because you have 500 over 100. So basically, you getting a force that is 5 times the input force. Now, to just show you how you can find also the reaction forces developed here at the pin A, you could continue with applying the forces in the, balancing the forces in the X and Y direction. So here, for example, AX positive. The X component of this guy would be NB, because of the angle 45 would be NB cosine 45. Therefore, if you put the 500 here, AX happens to be, let's see, 353.55, right? So in the negative direction, right? But the negative is just shows that the direction has to switch. And then in the Y direction, similarly, you have AY minus 100 minus 500 sine or cosine 45. In this case, actually, it doesn't matter. So if you use cosine here for the X, Well, let's just use sine here, right? So AY happens to be 453.55. And then if you want the resultant pin reaction, remember resultant pin reaction at A, you could go ahead and do square root of AX squared plus AY squared. So in this case, square root of 353.55, negative or positive, doesn't matter, you're squaring it, right? And this comes out to be about 575 newtons. Okay, so it was really a simple example of a machine, in this case a pliers, and you see how an input force of 100 is increased 5 times to a 500 at the output. Okay, as always, thanks for watching and listening, and if you like the videos, please subscribe. Thanks again.